Eighth grade math lesson 8.2 is solving systems by substitution. So in the previous lesson, we learned we've got linear equations. Oh no. Okay, it's fixed. Everything's okay again. We learned that we have linear equations. They can be jumbled up. We can fix them into the y equals mx plus b format. They make a line. If I have two equations, they will make two separate lines. And where they would meet is their solution. So that we learned how to solve those by graphing those linear equations, both of them, to see their meeting point, and that was their solution. It's easy. That was pretty handy. I think you guys felt like it was good. It's easy if you have graph paper and rulers handy, but you don't always have that. You might just have lined paper, and then finding that meeting point is difficult. Or if it's larger numbers, you don't want a graph that's gigantic. So there are two other ways that you can solve those without graphing them. One is by substitution, and that is what this lesson is going to be about. The other one is by elimination, and that's what next lesson will be about. So let's take a look at how we solve them by substitution. And it turns out looking like a bunch of math. Like you might take up a half a page or a full page for it. And so it seems like, oh, what a pain. But it looks awesome when you're done. You look like you're wicked smart when you're done. So just enjoy that. So steps are solve for a variable. I'll show you what that looks like. Then you'll substitute the expression in. I'll show you what that looks like. And then you'll substitute the value in to solve it. So first step. So here I have this expression or this equation and this equation. I'm going to choose one. Doesn't really matter which one. I'm just going to choose one of them. I'll choose this guy. I choose you. And I'm going to solve for a variable. I'm going to solve for the y. So that just is moving things around. So I'm going to go ahead and take this negative 3x plus y equals 1. I'm going to use inverse operation just to get this out of the way. Both sides of the equation, right? That leaves me with y equals 3x plus 1. When I say solve for the variable, doesn't mean I'm getting an exact number over here. I'm just getting one of the variables isolated. So I isolated the y. So that step is done. And so now I know y equals this. I don't know what number that is because I don't know what x is, but it does equal this. So I'm going to underline that. Now it says, substitute the expression, they mean this, for the y in the other one. So if y equals this, then I'm going to substitute this expression for the y in this equation. So I'm taking that 4x plus y equals 8, and instead of y, I'm going to substitute 3x plus 1 equals 8. That's from here. Okay. Now let's clean things up. Let's marry our like terms. I have 4x's plus 3x's. That is a total of 7x's plus 1 equals 8. I'm going to do inverse operations to isolate my variable. Subtract 1. I'm trying to isolate the x. That leaves me with 7x equals 7. X is being multiplied by 7, so I will divide. Inverse or opposite of multiply is divide. X, 7 divided by 7 is 1. So I have just found out that x equals 1 in this system of equations. So now I can move on to step 3. I will substitute that value of x into either of these. I'll go ahead and substitute into this one. So we're going to take the negative 3x plus y equals 1. And now that I know that x equals 1, I'm going to plug it in here, substitute it, right? We're doing substitution. And I will solve for y now. So negative 3 times 1 is negative 3. Then I'll use inverse operations to isolate the variable y. So opposite of negative 3 is positive 3 to both sides of the equation. Y equals 1 plus 3 is 4. So I have now x equals 1, y equals 4. The solution for this system of equations, the point at which those two lines will meet, is at 1, 4. 1 on the x, 4 on the y. That's how you do this. I know your brains are trying to digest that. It was a lot in one shot. So we're going to do another one. Okay, let's do it again so your brains can kind of figure this out as we go. It was a lot of information thrown at you at one time. Here is our system of equations. And we're going to go ahead and go through this step by step using the substitution method this time, like we did last time, instead of what we did in lesson 8.1, which was just graph it to find it. So step 1 says solve for one of the variables. So I could choose this equation or this one, either one, and solve for one of the variables. I'm going to choose this one this time, negative 2x plus y equals 1. I'll write it down here so we can focus in on it. And I am going to solve for one variable. I'm going to solve for that y because he's already alone, so that makes it easy. I always go for the variable that's already alone and doesn't have a coefficient in front of it. If x didn't have a coefficient and y did, then I would be isolating that instead. You have the choice to do that. So I'm going to go ahead and do the inverse operation here. Opposite of negative 2x is positive 2x. Just sending that whole term over. This leaves me with y equals 2x plus 1. So there's my expression for y. So I'm going to take this expression for y and plug it in for either of these on y. Probably this one, since I used this one already. I'm going to use this one. So this is step 2. I'm going to take the expression 3x plus y equals 11. That's that first expression here. But in place of y, I'm going to substitute this because it says y equals that. So I'll substitute that in. So I'm going to rewrite it. 3x plus, and that's y equals 2x plus 1. And then the equals 11 part goes in there. And now I use my skills that I've had. I can marry my like terms. 3x plus 2x equals 5x. Did that. Bring down what you didn't do. This is why I always just do one step, bring down what I didn't do. Now I'm going to go to step 3, which is substitute. Oh, no, not yet. We're not on that. We're still solving for x here. So we're going to solve for x. Inverse operation to isolate my variable. That gives me 10. X is being multiplied by 5. The inverse of multiplied by 5 is to divide by 5 to both sides of the equation. 10 divided by 5 is 2. All right, now I have finished step 2, and I know now that x is 2. So I can now take this x equals 2 and substitute it into either one of these. I'm going to go with this one, though, because this is negative, and I always try to avoid working with the negative. So I'm going to put it here, and then I will solve for y. So I'm at step 3. I'm going to take the top equation. And now that I know that x is 2, this will be 3 times 2 plus y equals 11. 3 times 2 is 6 plus y equals 11. Isolate the variable by using inverse operations. That's a positive 6. I undo that with a negative 6. And 11 minus 6 is 5. The meeting point of each of these lines will be at 2 on the x and 5 on the y. That's the solution for this system of equations. We will look at one more together if you need it. If you get it and you've got these steps copied down somewhere so they guide you through, you can pause or you could stop and be on your way. Or if you love listening to my voice, you can continue. But I'm going to do one more with you just in case your brain needs to see it one more time. Okay, this is number 5 on page 238, the your turn one. But some of you need a little still bicycle holding on the your turn one. So here it is if you need it. I have this system of equations. This is a line and this is a line. And I'm going to use the substitute method for finding the solution to where they meet. We're going to solve for one variable. I can use this equation or I can use this equation to solve for one variable. Now, take a look at these equations, right? I can move one of these terms over but each of them has a coefficient, so I'll be dealing with a denominator because I'll be dividing, and if it doesn't divide equally, I have this denominator hanging out in there. So I try as much as possible to avoid having to do any division, because this is being multiplied by 2 and this is being multiplied by -3. So I try as much as possible not to do any division. So this is not my first choice if I could avoid it. So I'm going to look at the next equation. I have x with just the one coefficient, or no coefficient showing, just one x, already no division, plus 6y. Well, I can move this term over, and then I don't have to do any division to isolate that x by itself. He's already 1x. So if I'm given that option in there, I'm going to choose that. So this is the one I'm going to do step 1 with, so that I don't have to try and divide out other coefficients. So we'll go ahead and take it up to the top, x plus 6y. I just wanted to think that through with you guys so that you can see like why you might choose one over the other. It doesn't matter which one you choose, but make it easy on yourself. Choose the one that makes it easier. So I will do inverse operation to isolate down to the x. That leaves me with x equals -6y and a positive 18. So there's the expression that I will use in place of x this time. So this is a nice one for you to see, that I could isolate either x or y, whichever one works best for you, given the information you've been provided. So now I'm going to choose either of these. Actually, I'm going to choose this one, but instead of x, I'm going to plug in that expression. So here's what we'll do. This is how this looks when you're dealing with that. 2x minus 3y equals -24. But now instead of x, I'm going to put this expression. So this is 2 times -6y plus 18. And then I just put down everything else. -3y equals -24. Use the distributive property. 2 times -6y is going to be -12y. And 2 times positive 18 is going to be positive 36. Bring down everything else that we haven't really done anything. They just get to keep hanging out. Combine my like terms. I have a -12y added to a -3y. That's -15y's. I was negative and I went even more negative. Bring down what we haven't done. Just do one bite at a time. Don't try and do too much or your brain gets overwhelmed. Now I'll do inverse operations. This is a positive 36, so I'm trying to isolate y, right? Opposite of positive 36 is -36. This leaves me with -15y still hanging out there. I went negative and then I went even more negative. I owed $24 and then I borrowed another $36. I owe even more. Add those together. I owe 60. Y is being multiplied by -15. Divide by -15 as the inverse operation, both sides of the equation. Don't forget that negative sign. That's where I make my most errors, is sometimes I drop that negative sign accidentally, and then I'm off by a negative. Negative divided by negative is a positive. 60 divided by 15 is 4. All that work to find out that y equals 4. Now that I know that, I move on to step 3, and I substitute the value of y into either of those two equations and solve. Let's use this one. So we have x plus 6 times 4 equals 18. So I used x plus 6y equals 18, but I substituted the 4 in for the y. Now I will calculate x plus 24 equals 18. Then I will use inverse operations to isolate the variable. X equals, so that's $18 in my pocket, but I owe 24. I'm still going to owe money. The difference between 24 and 18 is 6. I had to count that on my fingers. X equals -6. Solution, -6 on the x and 4 on the y is going to be the point at which this line and this line meet. That is the solution for this system of equations. I hope that this is helpful. Don't be afraid to rewind and hear the pieces again because it may need a few repetitions. Write these down to help you too. I think you'll do well, but this is just one of those things that just needs a lot of practice, that you just do the steps over and over, and then it really falls into place. So good luck, and let me know if you need help.